Welcome back to -7, day 2, completing the square, the sequel. Subtext, we were almost done the first time, but we thought we'd completed it, and it wasn't quite complete, but now it's about to be. Completing the square, day 2. Here we go. Let's jump in with a quick reminder why we do what we do on this channel. Why do we even need to bother with completing the square? Why is it important? Let's do a quick little refresher, okay? Well, completing the square is important to us because it allows us to solve any, and I said any, quadratic equation. If we're clever, now we have to do a little rearranging, a little clever math, but it allows us to do that. We can rearrange, we can make this happen. So completing the square is awesome because it allows us to solve any quadratic, even the ones that are factorable, even the ones where we might need to take or we were taking the square root before. Okay, and given a quadratic that looks like x squared plus bx plus something, what is that something? What is that something? And when I factor that something, what ends up in here? Well, in order to figure out what we add, to both sides, or to complete the square, we just take b, we divide it by 2, and then we square that. And whatever is in here is just b over 2 once it's factored in its factored form. Sweet! Let's have some practice with numbers. Let's practice completing the square on each of these examples. b is 12, so I would do 12 divided by 2, which is 6. Right? b over 2 squared. This is going to be, whoops, great start. 12 divided by 2 squared is 6 squared, which is 36. So we're going to add 36 to both sides. And this in factored form then would be x plus 6 squared. Okay? See if you can factor the second. See if you can factor this second one. On your markers, I go. All right, here we go. b over 2. b is -7. So I'm going to do -7 divided by 2 squared, which will end up being 49 over 4. 49 over 4, which as a decimal is something. It's something. 12.25. So we're going to, to complete the square here, we would add 49 over 4, which is 12.25. And if we were to factor that, it would just be x minus 7 over 2 squared, or x minus 3.5 squared. All right, the last one's a doozy. Whew! b over 2 squared. This is going to be fun. b over 2 squared equals 4 over 5 divided by 2 over 1 squared equals, let's see here. That's going to be 4 over 5 divided by 2 is times 1/2. Which will be 4 over 10 squared, which can be simplified to 2/5 squared, which is 4 over 25. So I would add 4 over 25 to both sides, and the factored form of this would be x plus 2 over 5. 2 over 5 times 2 over 5 gives me 4 over 25 and 2 over 5 plus 2 over 5 gives me my 4x squared. I forgot my squared there. Okay, perfect. Sweet. All right, so let's get warmed up. Let's do a couple completing the square questions. Let's do this one. I'm going to skip A. We're going to do this one and one more, and then we're going to learn something new. I'm pretty excited to teach this. Okay, remember those steps that we did last time? Step 1 for completing the square is make sure your constant is on the right. Guess what? Step 1, a check. We're done. Constant's on the right-hand side. Let's move on to step 2. Boy, that was easy. I'm pretty good at this completing the square stuff. Okay, constant's on the right-hand side, so we're good. So now we have to do the completing the square step. Remember, it's just add b over 2 squared to both sides. Easy. Easy peasy. B over 2, let's think about that. That's 8 over 2 squared, which is 4 squared, which is 16. 16. So I'm going to write this as x squared plus 8x plus 16 equals negative 10 plus 16. Great. What I do to one side, I can do to the other. Added 16 to both sides. We're treating them equally. Now this can be factored. This is a perfect square trinomial, so I can factor it as such. It's going to be x plus 4 times x plus 4. 4 times 4 is 16, and 4 plus 4 is 8. And right-hand side, we have regular old 6. Okay. So we actually just did step 3, which I didn't really write. Step 3 is this step right here. Step 3 is the factor step. Factor and simplify. So you factor the left side, simplify the right. Right? Negative 10 plus 16. Good to go. Step 4. Moving right along. Blue again. Square root. And solve. Square root and solve. So we'll end up with, if we take the square root of the left and the square root of the right, you'll end up with your two cases. Don't need to write the square root there. Square root of something squared is just itself, so this will be x plus 4 equals the square root of 6, but we have to consider the positive and the negative case. Now we subtract 4 from both sides, and you get x equals negative 4 plus or minus square root of 6. Sweet! So we have our two solutions. Are these real, or are they complex? Well, since there's no I, that means that we have two solutions, and they're real solutions, and they are numbers that I don't know exactly, but you could bust out your calculator, and why don't we do that? You know what? Why don't we get out a calculator? Let's say approximately what those darn things are. I should probably press the on button, plus the square root of 6. Ooh, negative 1.55. Okay, and that is rounded to the nearest hundredth, so be careful. Negative 4 minus the square root of 6 will give us negative 6.45. Special numbers. I want to be like the Bob Ross of math. Okay, those are our answers, completing the square. But I gave you a big warning last time. Last time I said, hey, completing the square, it only works in certain situations. All right? It only works when a equals 1. Do you guys remember this? Right here, our a value is 1. The coefficient of our squared term is 1, so we can complete the square. Why don't you guys take a crack at this one and get warmed up? Let's go quick. Go quick. Give it a shot. I'm going to do it too. I'm going to do it real quick. We're going to make it happen. Actually, you know what? We're skipping this one. We're skipping it. We're skipping it. We already did these last time. Watch the old video if you want to see me do one like this. Let's do this one. Yeah, this one's going to be fun. All right. I said, look out. Look out. We can only complete the square if if a is equal to 1, but here a is not equal to 1, so, oh man, we're out of luck. Just kidding. We're math students. We can force a to be 1 by treating both sides equally and dividing both sides of the equation by 2. We end up with x squared minus 7 over 2x plus 3 over 2 equals 0. Okay, so technically the first step in completing the square is to make sure that you have the constant, the a value equal to 1, and now we can officially start and put the constant on the right. So I'm going to subtract that, that 3 over 2 from both sides. So you'll get x squared minus 7 over 2x equals negative 3 over 2. All right. Okay, step 1 complete. Check. Constant is on the right. Now, I have to add b over 2 to both sides. Yuck. b over 2 squared to both sides. b over 2 is negative 7 over 2 divided by 2 over 1. You know how to divide fractions? That's going to be negative 7 over 2 times 1/2. Skip, change to multiplication, flip the fraction, and you'll end up with negative 7 over 4 squared. Negative times a negative is a positive, so our answer is going to be 49/16. Isn't that fun? So I am going to now add 49/16 to both sides of the equation, which will give us something. Now I'm going to turn 3/2 into 16ths, right? That would be multiplied by 8, negative 24 over 16 plus 49 over 16. So I just changed negative 3/2 to negative 24 over 16. Great. So I added 49 over 16. These two are the same number, so we're not really doing, we're just kind of, we're looking at stuff from a different angle here. The thing on the left is factorable, right? And the way that I know is because I have just completed the square, so I know that it is. Okay, and the thing that goes on the inside is always b over 2. Negative 7 over 2 is b. b over 2 was, in simplified form, negative 7/4. So I'm going to write minus 7 over 4. Boom. And then on the right, I got to simplify. So factor, simplify, simplify. Negative 24 plus 49 is, oh, that makes me happy. 25 over 16, those are both perfect squares. That makes me really happy. So now we can take the square root of both sides, and our two cases are x minus 7 over 4 equals plus or minus, take the square root of 25 and 16, and we will get plus or minus 5 over 4. Great. Not quite done yet. Our two solutions are 7 over 4 equals, oh, not equals. It's been a long day. It's been a long day. Plus or minus 5 over 4. So now let's calculate. Don't leave your answer like this because these are numbers. These are going to give us number answers. Our two answers are going to be x equals, they both have the same denominator. 7 plus 5 is 12 over 4, which is 3. Ooh. And x equals 7 minus 5 is 2 over 4, which is 1/2. So our two solutions are 3 and 1/2. And that was much rejoicing. Okay. Perfect. Perfect. Great. The next thing that we need to do to set up for today's lesson is I want you to recall, this is a good thing for us to do, a good thing for us to review before the end of the chapter. Remember, the easiest way to graph a quadratic is if it is in vertex form. Now, graphing in standard form is just fine. It's perfectly fine. But vertex form is a lot easier. With standard form, remember we had to find x equals negative b over 2a, and then find the vertex, and then find the y-intercept, and then move stuff around. And it was like, okay, great, but this clearly just has the same shape as the parent function. So I can take this graph, and it's going to be the exact same shape as the parent function, or y equals x squared, except it's going to be shifted to the left 3 and down 5. So I'm going to take my parent function, and I'm going to, it looks like this, remember? Can reflect those points. Boom. I'm going to take this, and I'm going to shift it left 3 and down 5. So that's going to look like, let me change colors. Okay, and then, cool. There's our parabola. Okay, that's vertex form. This is nothing new. Oops. Try that one again. If I could have one superpower, probably be perfect parabola drawing skills. Yeah, we shifted to the left, we shifted down, we're done. Pretty much it, okay? Now here's the deal. What we're about to do in this lesson is less of a good idea time-wise on an exam. I might ask you to do this. It's more of like a math flex. It's like the algebra equivalent of wearing designer jeans. No, that's a bad metaphor. It's a math flex. Okay, so what we're about to do. So graphing in vertex form is the easiest way to graph. It's easier than standard form. This is in standard form, but what we are going to do is I'm going to force it to be in vertex form. And you're probably thinking, oh dang, it's gonna be tough. No, it's really not that bad. It's really not that bad. I'm gonna show you a little secret about how you can do this. Now you can totally graph this using standard form. That is just fine. But let's begin by putting this in vertex form. And you're saying, well, Mr. Sugg, I don't know how to do that. It doesn't look like it. There's no parentheses. What's going on? So I'm going to rewrite this. Y equals x squared minus 10x. Now, what I'm going to do is going to weird you out. I'm telling you, it's going to be a little weird. I am going to add 0. You're saying, why would you do, okay, what? Does adding 0 change this? It doesn't change my quadratic, right? Adding 0 doesn't change anything. But I'm not going to use regular 0. I'm going to use a clever form of 0. The 0 that I'm going to add, this is like math flex wizardry. The 0 that I'm going to add is a special form. It is going to be, what is going on? Why did those appear there? It is going to be plus 25 and minus 25. Now don't forget, I still have my minus 2. So what happened here? I took my quadratic, I added 0, and then I really did a clever form of 0 that is 25 and negative 25. Those will subtract to 0, but if you pay close attention, you'll notice that this thing right here is a perfect square trinomial because I completed the square. I did negative 10 divided by 2 is negative 5 squared is positive 25. So now what I can do is I can turn this into x minus 5 squared, and then negative 25 minus 2 is minus 27. So how can I graph this? Let's describe it with transformations. It's now in vertex form. Recap, added 0, used a really clever form of 0 that allowed me to take the first 3 terms and turn them into a perfect square trinomial, and then I combine the last 2. So this one for us to graph is a little bit tough. Our vertex is at 5, so our vertex will be over at 5 and down at negative 27, because we would shift our parent function to the right 5 and down 27. But that's off our graph. So I'm going to change the y scale. I'm going to say change the y scale to 5s. So instead of going down, I'm going down 5. Now the x scale is still 1s. Y scale is in 5s. X scale is still 1. So I'm going to go down 1, 2, 3, 4, 5. So there's negative 25. Okay, negative 27 is going to be a little bit further, so it'll be right about there. Okay. Now, where does this thing, how can we get other points on this graph? Well, I think an easy way to quickly graph this is realize that it crosses at negative 2. So what does our parabola look like? Well, it's going to look kind of like this big U that comes up, or big shape that comes up over here like so, and then turns around like this. Now the rest of it's off our graph, but you kind of have the basic idea. Okay, so don't focus about the graph. This one is actually kind of a pickle. The next one's going to be a little bit easier. Let's take a look. Yeah, you guys try to graph this one. So I want you to try and force this into vertex form, and then give it a graph. Try it on your own. Here we go. All right. I'm going to add 0. So this is going to be y equals x squared plus 2x. My form of 0 plus 0 plus 3. You really don't have to write this step. Some students like it as like a little placeholder so you can see what's happening. So this is plus 2x. I'm using the b over 2 squared. B is 2, so 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1. Now, I'm also going to subtract 1. Now, the reason I can't just add 1 is because then we'd be treating the sides, we'd be treating them unevenly, if that makes sense. So I'm just adding this clever form of 0. Okay, and we end up here with x plus 1 squared. And then negative 1 plus 3 is plus 2. So the first 3 terms became x plus 1 squared, and the last 2 terms became plus 2. So my vertex is going to be to the left 1 and up 2. And it's got the same shape as the parent function. So we'll go over like this, like like that, and like that. We got our graph. Boy! Ooh, whoa, holy cow, I think I might have superpowers. There we go, look at that. I know what you're saying. Mr. Slagle, this is ridiculous. Both of these were super easy because they have the a value 1. You're gonna give us one that doesn't have the a value 1? Can you do this process on one that doesn't have the a value 1? And the answer is yes, we can. Okay. If you want to graph 2x squared minus 6x plus 1 in vertex form, now it is a little bit harder to do because of this fact, but we can still force a to be 1. We can still divide both sides by 2. You end up with y over 2 equals x squared minus 3x plus 1/2. Okay, so I just 2 divided by 2, negative 6 divided by 2, 1 divided by 2. Great, now I got my right side, kind of looks like looks like a trinomial. It's a little weird, we get some fractions. So all you have to do is don't worry about the y over 2. We're gonna fix that in a little bit. First things first, let's go ahead and write this as a perfect square trinomial. So I'm going to add my clever form of 0 yet again. B is negative 3. B over 2 is negative 1.5. And so this is going to be x squared minus 3x plus 2.25 minus 2.25 plus 1/2 or plus 0.5. So my clever form of 0 that I added was 2.25. Now we're going to factor the first three terms and then simplify the second two. So factoring our first three is just x minus 1.5 squared, just b over 2. Okay, and our last three terms is negative 2.25 plus 1/2. Well, one's negative, one's positive, so I think that is minus 1.75, right? Yeah. Okay, cool. I'm not done yet. I can't graph this because this is not, it doesn't say y equals, it says y over 2 equals. So all I have to do to solve that problem is come through, multiply. I'm basically undoing the work I did. Multiply the left side by 2, multiply the right side by 2. And you end up with y equals, the 2's cancel here, and you got to distribute that 2 to each of the terms. So this is going to be 2 times x minus 1.5 squared and double 1.75, which is minus 3.5. Okay, and so now we can graph this. I take my parent function and I'm going to shift that to the right 1.5 and down 1, 2, 3.5. So my vertex is right here. And now if we're really being, clever, if you're really struggling and you want to make it happen, remember this thing is always the y-intercept. You can look back here and say, hey, look at that. That's my y-intercept, so I can reflect that point across my axis of symmetry, which is just this value. And if you didn't see that, then you can just graph it the old way. Remember, I know with my parent function, I'd go over 1 from the vertex up 1. So 0 squared is 0, 1 squared is 1, right? Remember that shape of the parent function here? So my a value now is 2, so I can use that to kind of unlock some points. If I go over 1, I'm not going to go up 1, I'm going to go up 2, reflect. If I go over 1, 2, I'm actually going to go up. Normally I'd go up 4, now I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And reflect. Oh, yuck. Hold on. All right, there's our parabola. Oh, she's a beaut. Look at that. What a beaut. Oh, man, look at that parabola. Get out of here, parabola. Phew. Okay, you guys try this one. I want you to manipulate the parabola so a is equal to 1, then completing the square to make a perfect square trinomial and put it in vertex form. On your mark, get set, go. And Slagle's in. Yay! Divide by -1. And we get, whoa, hold on to your hats and your chairs. Whatever else might keep you stationary. This is going to be, negative y equals, all the signs are going to change. The y changes, x squared changes, 6 changes, and the -1 changes to +1. So I've just kind of essentially stored the -1 over here in the y, and now I'm going to complete the square on what's left. So we'll get -y equals x squared minus 6x, b over 2 squared, -6 divided by 2 is -3, -3 squared is +9. minus 9 plus 1. So simplifying, we'll get x squared. Oops, we got to factor that first three terms. Factoring the first three terms, you'll get x minus 3 squared. And then the second two will form, so these three turn into this. These two turn into negative 8. So there it is. It's going to go to the right 3, down 8. Oh no, we can't move it yet. Oh no, Mr. Slagle, you almost made a mistake. Don't move it yet. Uh-oh. Don't move it yet. We're not done. We gotta, doesn't say y equals. We gotta multiply both sides by -1 or divide both sides by -1 to get it back into its original shape. So minus 1 divided by -1. So this needs to be divided by -1, so that all the signs are going to change. So it'll be negative x minus 3 squared plus 8. Hey, hey! So I'm going to the right 3. I'm going to the right 3. I'm going up 8. Up 8 is like right there. Cool. Cool, and this opens down. It's the same shape as the parent function, but it's going to open down. What? Sweet. Look at that. Oh, parabola. You guys, you've done a lot with parabolas now. You should feel happy of yourselves. You should feel happy of yourselves. Great. That's it. Thanks for watching. Stay tuned for more algebra content from the Mathnasium, where we uncover the mathematics, the breaking, cutting-edge mathematics that was coming out 2,000 years ago. Yeah, that's what I'm talking about. I don't even know how you could possibly wait for the next episode of the Mathnasium, where we uncover an ancient secret. This is like the History Channel. It's like an ancient secret. The most powerful of formulas will be discussed next video. All right, I don't want to get any emails at 2, 3 in the morning like, can you give me a hint? What's in your next video? None of those. All right? Can't just be making videos all the time. But you're going to have to stay tuned. And I've run this joke a little too long. Thanks for watching. Hope you're having a great day. And also a great tomorrow. We'll see you later.